Today, we're getting into the latest Tesla news, including multiple Tesla Cybertruck prototypes spotted testing together for the first time. Elon Musk explains why too much electric vehicle range does not make sense. Tesla Model Y from Giga Texas is just one EPA approval away from first deliveries, and much more. Before we start, don't forget to subscribe to our channel and press the bell icon to never miss an update about Tesla or basically anything related to the billionaire Elon Musk. So let's get into it. First up today, Tesla has entered into a legally binding term sheet agreement with Australian lithium producer Core Lithium Limited. Under the agreement, Core Lithium will supply Tesla with up to 110,000 tons of Li-2O spodumene concentrate over 4 years. Core Lithium is thrilled to have reached this agreement with Tesla and look forward to further growing this relationship in the years to come. Tesla is a world leader in electric vehicles, and its investment in offtake and interest in our expansion plans for downstream processing are very encouraging, said Core Lithium Managing Director Stephen Biggins. Core Lithium will supply Li-2O spodumene concentrate from the Finniss Lithium project near Darwin, the capital of Australia's Northern Territory. The project received all approvals from the Northern Territory government and was fully funded after raising $116 million from institutional investors and shareholders. Core Lithium also signed a 4-year offtake agreement with Ganfeng, agreeing to provide $24 million in new equity, subject to Chinese government approval. Construction on the Finniss project began last year. Core expects to produce lithium concentrate for the first time by the fourth quarter of 2022. About 80% of the project's initial production is covered by Core's 4-year offtake agreement with Ganfeng and Yahua. In November 2021, Tesla and Ganfeng Limited reached a lithium supply agreement for battery-grade lithium products. The Tesla-Ganfeng deal starts in 2022 and lasts up to 3 years. Tesla's term sheet agreement with the Australian lithium producer is subject to completion of negotiations and execution of a final product purchase agreement on August 27, 2022. The definitive purchase agreement is expected to begin supplying by July 31, 2023. Subject to execution of a definitive agreement, Core supply to Tesla is scheduled to commence in 2H 2023 and will cease on the date that is 4 years after commencement of supply or until a total of up to 110,000 dry metric tons has been delivered, Biggins explained. Core's plans for the Finniss project include developing downstream lithium chemical processing in the Northern Territory. It is the company's long-term plan, which Core refers to as Stage 3 expansion. Tesla has agreed to support and assist Core with its Stage 3 expansion plans, subject to the execution of a definitive agreement. Tesla has been pushing lithium supply deals lately as it makes progress with 4680 battery production. Last month, Tesla signed a 5-year spodumene concentrate supply agreement with Liontown Resources. In a recent press release, Tesla battery partner Panasonic announced that its energy division will build a 4680 battery production facility at its Wakayama factory in western Japan. Mass production of the new battery cells at the plant is expected to begin in the fiscal year ending in March 2024. The plan is to help Panasonic expand its electric vehicle battery business globally. While the company's mass production timeline seems conservative, Panasonic explained that it is currently developing the 4680 cells at multiple locations in Japan. Mass production plans for the 4680 battery are being developed today in preparation for the full rollout of future batteries. Multiple updates are expected at Panasonic's Wakayama factory. Along with structural improvements to the site, 2 additional battery production lines and utilities are expected to be built. Productivity, verification, and mass production of the 4680 battery itself will follow. To contribute to the rapid adoption of EV, Panasonic has been working to enhance its lineup of automotive lithium-ion batteries. Currently, Panasonic is developing a new high-capacity lithium-ion battery, the 4680, in multiple locations within Japan. The company will progressively develop production capabilities in preparation for the full rollout. Along with structural improvements, 2 additional production lines, as well as utility facilities, will be established at the Wakayama factory, and productivity, verification, and mass production are set to begin in the fiscal year ending in March 2024, Panasonic wrote in its press release. While Panasonic hasn't disclosed customers for its 4680 cells, it wouldn't be surprising if longtime partner Tesla becomes one of the biggest buyers of the Japanese company's upcoming battery. After all, Tesla and Panasonic have had a working relationship built over the years, as evidenced by the 2 companies' operations in Gigafactory, Nevada. Panasonic is still pushing the limits of what its batteries can do. Back in January, the Japanese company revealed that by the end of 2022, it would be producing batteries at Tesla's Gigafactory, Nevada, using recycled battery components from redwood materials. The announcement is significant, as it underscores that EV batteries are only going to get cleaner and more sustainable over time. Next up today, two working Tesla Cybertruck Alpha prototypes were recently spotted testing together for the first time. The sighting, which was recorded in the Fremont factory, featured one refined Cybertruck prototype and another unit that had several exterior parts missing. The images were shared on social media by electric vehicle group The Kilowatts, which recently visited the California-based electric vehicle plant. Initially, sightings reported by Tesla community members pointed to the EV maker testing one of its updated Alpha prototypes on the facility's test track. Later images taken during the day revealed that there were actually two working Cybertruck prototypes that were being tested that day. Interestingly, a prototype Cybertruck seen at the Fremont factory was missing several parts. Although the car moves on its own, it doesn't have any doors and it doesn't have a hood. Its tailgate also appears to be missing. What's more, the car doesn't appear to have a rear wall installed. This suggests that Tesla may be looking to implement a pass-through system for the Cybertruck, which should allow owners to transport long items without having to drop the vehicle's tailgate. The Cybertruck's pass-through system has been teased since the company unveiled the truck in late 2019. Photos taken of the Cybertruck's second-row seats show the car's rear seats may be designed to flip or fold down. This hints that Tesla may be considering optimizing the Cybertruck's available storage space, even beyond its massive vault and trunk. The Cybertruck was originally set to enter limited production in late 2021, though that date has been pushed back to around 2023, based on previous comments from CEO Elon Musk. The vehicle has undergone significant changes since its debut in late 2019, with parts such as the door handles removed. A 4-motor variant, which was not announced during the vehicle's initial launch, was also revealed as the first version to go into production at the Gigafactory in Texas. Moving on to the next update, Elon Musk commented a few days ago that Tesla could have had a Model S that could travel 600 miles on a single charge. However, Tesla decided not to pursue an industry-leading metric because it would negatively impact handling, efficiency, and overall performance. We could have made a 600-mile Model S 12 months ago, but that would have made the product worse IMO, as 99.9% of time you'd be carrying unneeded battery mass, which makes acceleration, handling, and efficiency worse. Musk said in a reply to Holmar's blog, who stated Lucid may have been the first to deliver a 500-mile EV, but Tesla would be the first to produce it. Even our 400-plus-mile range car is more than almost anyone will use, the Tesla CEOs added. The bow to ease the range anxiety of new EV owners will finally settle completely. However, there are still too many people concerned about where they will be able to charge their cars, thinking that gas stations are everywhere, but EV chargers are not. While this is true, EV chargers are more available than many may think. In even rural south-central Pennsylvania, there are about 17 EV chargers, including an 8-stall Tesla supercharger. Even so, concerns about how much range is enough are still circulating in the community of potential EV buyers. Everything requires sacrifice. While most passenger gasoline vehicles can go about 400 miles on full gas, ABC News says the average American only drives 16 miles a day for work. U.S. Census data suggests Americans spend around 27.6 minutes driving to work one way. Hundreds of miles of range are not completely necessary. As Musk said, more range usually means more battery, which increases mass and undercuts the fun driving experience that EV are lauded for. The Tesla Model S has a range of 375 miles and at one point exceeded 400 miles. The Model S Long Range Plus has a range of 402 miles, one of the main reasons being significant mass reduction. Mass is the enemy of both efficiency and performance, and minimizing the weight of every component is an ongoing goal for our design and engineering teams, Tesla said in a blog post announcing the 400-mile Model S in June 2020. Several lessons from the engineering design and manufacturing of Model 3 and Model Y have now been carried over to Model S and Model X. This has unlocked new areas of mass reduction while maintaining the premium feel and performance of both vehicles. Additional weight savings have also been achieved through the standardization of Tesla's in-house seat manufacturing and lighter weight materials used in our battery pack and drive units. Interestingly, Tesla has several vehicles on the road with an estimated range of over 400 miles. The Cybertruck's tri-motor powertrain could lag behind the rumored quad-motor variant, which has a range of 500 miles rating when Tesla still has the vehicle's configurator. With the new 4680 battery, Tesla's vehicles will likely be able to hit the 400-mile threshold without sacrificing much of what Musk says is performance or efficiency. The next-gen Roadster, which has sat on Tesla's back burner for several years, also has an incredible 600 miles of range. The Roadster may be a special exception to the mileage rule, but due to the astronomical expectations placed on the vehicle, including its hovering ability, the excess battery weight could affect the Roadster's 1.1-second acceleration from 0 to 60 and its handling to its small, sporty frame. Hundreds of Tesla Model Y all-electric crossovers have been spotted at various locations in the Texas Gigafactory over the past few weeks, some of them in transporters sent to an unknown destination. However, haulers may soon be back for another logistical task, picking up Austin-made Model Ys and shipping them to customers. Tesla will be able to start deliveries of its Austin-built Model Y all-electric crossover from its Gigafactory in Texas after the EPA approves the vehicle. Currently, the Model Y from the Gigafactory in Texas, which is producing Tesla's latest 4680 cells and new structure battery packs, has yet to receive its Certificate of Compliance, a document required for the vehicle to enter commerce. A Certificate of Compliance is a valid EPA approval for a vehicle to enter commercial circulation. If it is introduced into commerce, the vehicle must have a Certificate of Conformity. These certifications are valid for a single model year, and new model year vehicles enter EPA testing facility in Ann Arbor, Michigan, each year to confirm that they meet EPA emission standards. Prior to offering a vehicle for sale, all car lines in the light-duty sector must be certified and fuel economy test data representing each model type must be submitted to EPA, the EPA said to Teslarati in a statement. EPA can confirm that Tesla has received a Certificate of Conformity for the 2022 Model Y Long Range AWD, Model Y Performance AWD, and a certificate for the Model Y RWD. These test groups were certified by the EPA last year, and the 2022 Model Y Long Range AWD and Performance variants received certificates of compliance on November 1st, 2021, expires until December 31, 2022. The 2022 Model Y RWD, which is the variant Tesla didn't end up selling, received a Certificate of Conformity from the EPA on September 28. The Tesla Model Y builds in Austin will also be a 2022 Model Y, which means it's technically compliant with the EPA Certificate of Compliance, especially since the manufactured geographical location does not determine whether a vehicle is EPA compliant. EPA does not use build locations as descriptors for new test groups or certificates of conformity, the agency said. Instead, updates to vehicle battery packs could prompt EPA to consider recertifying vehicles, even if the car was changed for the same model year. However, the changes made to the vehicle prompted the EPA to certify the Austin-built Model Y separately. Previous Model Y versions, even 2022 models built at the Fremont factory, have not yet used Tesla's 4680 battery pack or structural battery pack. Instead, the Model Y, built in Fremont, uses the automaker's previous battery chemistry, 2170 cells. When the EPA certifies Tesla's 2022 model year in August 2021, those certifications are for previous battery packs. 4680 batteries are very different from 2170 batteries in terms of power, range, and efficiency. As a result, the Model Y in Texas will have a very different rating than previous models in Fremont. Austin's Model Y requires EMPG ratings for fuel economy, .gov, and Monroney stickers. Once Tesla is granted a Certificate of Conformity for Model Ys that are set to be produced at Gigafactory, Texas, the automaker will be able to deliver the vehicles to customers. Documents obtained by Teslarati show that Tesla applied to certify the AWD and performance variants of the Model Y together, while the RWD version of the car was certified separately. The document states that each variant of the car meets California Air and Resources Board standards, as well as federal emissions standards used by states that do not meet CARB standards. Texas withdrew its intention to adopt the CARB standard in 2007, state documents show. CARB-compliant states include New York, Massachusetts, Vermont, Maine, Pennsylvania, Connecticut, Rhode Island, Washington, Oregon, New Jersey, Maryland states, Delaware, and most recently, Colorado, adopted this year's standards. The EPA cannot predict the timing of the certification process and will vary by vehicle. A rough timeline can be obtained by determining when Tesla will submit a vehicle application and when the vehicle will receive a Certificate of Compliance. Tesla's filing date for the 2022 Model Y Long Range AWD and Performance variants is October 21, and the Certificate of Conformity is November 1st. However, this car has the previous model year and uses the same battery pack. Since the 4680 packages have not been previously tested by the EPA for passenger cars, the time frame may be faster. When Tesla submitted its 2021 Model Y application, it was the vehicle's first certification process. Tesla submitted the application on December 13, 2019, and the Model Y received a Certificate of Conformity about a month later on January 8. If Tesla submitted an application for the new Model Y when it announced on January 26 that it was awaiting certification, deliveries could be approved in the next few days. So what do you guys think about this? Let us know in the comments below. And most importantly, if you wish to be updated on every single topic related to Elon Musk, you should consider subscribing to the channel and pressing the bell icon. Also, thank you for watching the video. This is us signing off. See you guys in the next one. Until then, peace.